Let's look at the binomial probability problem. So anytime we have a binomial distribution and we want to find a probability, we need three numbers. Okay, we're going to need n, the number of trials, and it's okay if you think about this like sample size. Okay, it's the same idea. We also need p. P is the probability of success on one trial. And remember, when we're talking about a success, we're just talking about the event that we're counting, not necessarily that it's good or bad. Okay, and specifically, we're only looking at if we do our experiment one time, what's the probability of success. And then the third number we need to come up with a probability is x, the number of successes that we're looking for. Okay, so let's look at a problem in Hawks. Okay, if we look at this one, remember we're looking for our three numbers n, p, and x. So if we look at this one, it says the magazine mass marketing company has received 16 entries in its last sweepstakes. They know that the probability of receiving a magazine subscription order with an entry form is 0.6. What is the probability that exactly 10 of the entry forms will include an order? Okay, so looking for n, our number of trials, it says that we have 16 entries. So n is 16. It says they know that the probability of receiving a magazine subscription is 0.6. So that will be p. And then what's the probability that exactly 10 of the entry forms will include an order? Okay, so we're calling having an order a success, and we're looking for exactly 10 of those. So since we're in the case where we want exactly some number of successes, we can go to our tables, or you can use a calculator. Okay? There's nothing wrong with using a calculator to figure these out, but if you don't have a calculator that will do binomial probabilities, then we can use the tables. So since we want x to be exactly equal to some number, then we're going to use this binomial probability table. Okay? So it says we have an n of 16, so we'll go down to 16. P on this problem is 0.6, so we want the column for 0.6, and then we want exactly 10 successes, or in other words, we want x to be exactly 10. So we get our probability here of 0.1983, and I'm just going to click copy these values, and then we can paste those right into the box, and there's our binomial probability.